This is Algebra 2. This is test number 11. We got through section 5.7 doing inequalities of quadratics. Number 1 says graph f of x equals x squared plus 3x plus 1. So x squared plus 3x plus 1. Label the axis of symmetry and vertex. Okay, what we need to do is we need to find the x value. X is negative b over 2 times a. This is in standard form where the coefficient of x squared is a, the coefficient of x is b, and then the constant term is c. So we take that b value, negative b is negative 3, over 2 times the unknown value, or the unshown value, a is 1. So your x value, x, is negative 3 over 2. And when we graph that, we're going to look at that as negative 1.5. It'll be easier to graph. Once you have x, though, you need to use that to find y. F of x is considered y. So go back to your original equation. F of x equals x squared plus 3x plus 1, where we'll plug in the value that we just found for x, negative 3 over 2 and negative 3 over 2. So when we simplify this, negative 3 over 2 squared, negative 3 times negative 3 will be 9. 2 times 2 will be 4. Plus 3 times negative 3 is minus 9 over 2 plus 1. So y, we're going to simplify all of these fractions. In order to do that, we'll make all of our denominators common, all of them the same. We'll make them all say 4 at the bottom, since 1, 2, and 4 all go into the number 4. So 9 over 4 stays just like that. 2 needs to multiply by 2, so negative 9 needs to multiply 2 to make it negative 18, and 1 multiplies by 4, so does the top. So we have, and it's positive. So that'll give us our y value. Keep your bottom number the same, y. For y, and it's 4, 9 minus 18 is negative 9. Negative 9 plus 4 is negative 5 over 4. So we have x value and a y value, negative 3 over 2 and negative 5 over 4. Negative 3 over 2 is the same thing as negative 1.5. And negative 5 over 4 is the same thing as negative 1 and 1/4. So that is your vertex once you have your x and your y. So when you graph your quadratic, your x equals negative 1.5. Draw ourselves a few tick marks to where we can show everything we need to show. But negative 1.5 is going to be our axis of symmetry. So at negative 1.5, so halfway between 1 and 2, or negative 1 and 2, better yet, that is your axis of symmetry. And the vertex is negative 1.5, negative 1 and 1/4. So negative 1.5 and negative 1 and 1/4. Our second one will be right past negative 1. So negative 1.5. That's our vertex. So when we move to the right to the next nearest whole x value, that next nearest whole x value is negative 1. So we'll plug in negative 1 into our equation. So that's going in place of x. So our equation says y equals x squared, or negative 1 squared, plus 3 times x, 3 times negative 1 plus 1. So our y value, when we simplify this, negative 1 squared is 1. 3 times negative 1 is minus 3 plus 1. So 1 minus 3 is negative 2, plus 1 is negative 1. So your y value, when your x is negative 1, your y value is negative 1. So that is your second point, negative 1, negative 1. So from your vertex, negative 1, negative 1, your point will be about right there. And remember, you can mirror that on the other side of the line of symmetry for your other point. Then we just need to find one more point. And this will be the easiest one for us to find, because it'll be the next x value, which will be 0. So when we plug in 0 into the original equation, y equals 0 squared plus 3 times 0 plus 1, 0 plus 0 plus 1, so y equals 1. So when x equals 0, y equals 1. So that's your last point to plot, 0, 1. So at 0, 1 is your third point. And again, you mimic that on the next x value over, which would be negative 3. So you mimic it on the other side of the line of symmetry, and you can draw your graph to match that. So your axis of symmetry, again, is the first thing you found, your x value. X equals negative 3 over 2. And your vertex, if we would label it, your vertex would be this point at the bottom right here, which we found out originally is negative 1.5, negative 1 1/4. Number 2 says f of x is less than or equal to negative 2x squared minus 2x minus 1. Remember, f of x is the same thing as y. So you're going to find x the same way, though. You find x by saying negative b over 2a. So negative b is negative. This is ax squared plus bx plus c. So negative b is negative 2, which is going to turn into positive 2 for us. And it's over 2a, which is 2 times negative 2, which is going to turn into negative 4. So x is going to be negative 2 over 4 or negative 1/2. So now that you have your x value, use that to find your y value. So just go ahead and plug in. This is y, and we'll use this as equals for right now. Negative 2 times x squared minus 2 times x minus 1, and plug in that value that we just found, negative 1 over 2, the one we found for x. Negative 1 over 2 squared is positive 1 over 4. That multiplies by negative 2. Remember, that's over 1 where you can multiply fractions. This one's over 1 as well. Negative 2 times negative 1/2 is a negative times a negative is a positive 1 minus 1. So when we simplify this, the number 2 goes into negative 2 negative 1 time and into 4 twice as we cross cancel. So that'll leave us with negative 1 over 2 plus 1 minus 1 is plus 0. So we have our y value also at negative 1/2. So when we put both of these two together, they give us our vertex of our quadratic function. Your vertex is x comma y. X is negative 1/2. Y is negative 1/2. So you graph that as your vertex. We know that this picture is going to open down since a is a negative value, so we don't need to show anything above negative 1/2. So x's value is negative 1/2, so that is here. So your axis of symmetry runs at 1/2, and your vertex we found is negative 1/2, negative 1/2. So negative 1/2, and then go down on y to negative 1/2. So that's going to be the top of our parabola. We need to plug in 2 more values to find um, the other 2 points that we can mimic on the left side. So if we go to the next x value from negative 1/2, we go to 0. So plug it into the original equation. Y equals negative 2 times 0 squared minus 2 times 0 minus 1. So anything 0 squared is 0. Anything times 0, this is going to give us 0. Negative 2 times 0 will be plus 0 minus 1. So y equals negative 1. So when you plug in 0, we get negative 1. So your ordered pair is 0, negative 1. So your second point is 0, negative 1 is right there. And again, we can mimic that one on the other side of the line of symmetry right there, a half over. So we need one more point to graph. The next x value over is 1. So when we plug in 1, y equals negative 2 times 1 squared minus 2 times 1 minus 1. 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 times 1 is negative 2 minus 1. Negative 2 minus 2 is negative 4 minus 1 is negative 5. So y's value when you plug in 1 is negative 5. So your ordered pair would be 1, negative 5. You plot that last point at 1, negative 1, 2, 3, 4, 5. There is your last point. And mimic that one on the other side. Go one more unit of x to the left and go down to your y value of negative 5. Now that you have 5 points that you can plot, look and see if it's going to be a solid line connecting these points or a dashed one. We have less than or equal to. Remember that or equal to part means it's going to be solid. So connect your 5 points on both sides to show your parabola. And then since this is less than or equal to, we have to shade one point or the other. Remember, you need to pick one point that you can plug in to test the truth value. The truth value, the easiest one to plug in is 0, 0 if the thing's not going through it. So it's not going through it, so we can plug that in. In place of your original y, 0 is less than or equal to negative 2 times 0 squared. Anything squared, 0 squared is 0. Anything times 0 is going to be 0. Minus 2 times 0 is minus 0 minus 1. 0 is less than or equal to negative 1. You check this one at its truth value. 0 is not less than or equal to negative 1, which means everything on the outside of the parabola is wrong. So that means everything on the inside of the parabola is correct or is right. So number 3 says graph f of x. Remember, again, that counts as y is greater than or equal to negative 2x squared plus 4x. You need to find out what x's value is, just like we've been doing. X equals negative b over 2a. So negative b would be negative 4 over 2a is 2 times negative 2. So that's going to make it a little bit quicker for us. Negative 4 over negative 4. So your x value is 1. So use that to find out what your y value is. So y, and we'll call this equals for a second, equals negative 2 times our new x value is 1 squared plus 4 times, again, our new x value is 1. 1 squared is 1 times negative 2 is negative 2. 4 times 1 is plus 4. Y equals negative 2 plus 4, or y equals 2. So when our x value is 1, our y value is 2. So our vertex is going to be 1, 2. And we know that this graph is opening down since its a value is negative. So we don't have to draw anything above 2 on our y-axis. But we're going to have to draw things going down. So add a few going down. So your line of symmetry is at x equals 1. So where x is 1, try to make that a little straighter than I did. That's your line of symmetry. Your vertex says 1, 2. So at 1 and then y's values 2 is its highest point. So go to the next x value to the right. Its next x value is 2, and plug that in to your original equation. So when we plug in 2, when x equals 2, y equals negative 2 times that x value, 2 squared, plus 4 times 2. So 2 squared is 4, and 4 times negative 2 is negative 8. 4 times 2 is plus 8. So y equals negative 8 plus 8, or y equals 0. So when x is 2, y is 0. So your ordered pair is 2, 0. So at 2, x value, and 0 for your y value. And again, go over 1. That's 1 to the right. Go over 1 to the left and mimic it on the other side of the line of symmetry. And go to the one more point to the right will be x equals 3. So y equals negative 2 times 3 squared plus 4 times 3. 3 squared is 9 times negative 2 is negative 18. 4 times 3 is plus 12. So y equals negative 6. So when x is 3, y is negative 6. So your ordered pair would be 3, negative 6. Again, we'll plot that one at 3, negative 1, 2, 3, 4, 5, 6 for your third point on the right. And do the same thing one more unit over on the left and go down to negative 6. So that's what your parabola is going to look like. Again, this tells you that it is a solid line because it says or equal to. So connect your points. Do the same thing here. But then what we have to do is we have to determine if we're going to shade the right-hand side, if we're going to shade inside of it or outside of it. Normally we would try to use 0, 0, but 0, 0 is not an option here. So we use a point that's not on the line. And let's say we'll use this point 1, 0. That's inside of the parabola. So we want to see if we have a true statement or not. So we have y is greater than or equal to negative 2x squared plus 4x. And we'll plug in 1, 0. So y is greater than or equal to negative 2. Now, make sure since we have different ones, 1, 0, you remember that x is 1 and y is 0. So we want to see if it's a true statement. In place of y, we'll plug in 0 is greater than or equal to negative 2 times 1 squared plus 4 times 1. 1 squared is 1. 1 times negative 2 is negative 2. 4 times 1 is plus 4. So 0 is greater than or equal to 2 is what you have to check for truth value. That is not true. 0 is not greater than or equal to 2. So that means everything inside is going to be wrong, which means you have to shade everything outside of the parabola.